Assalamu alaikum warahmatullah. Welcome to Data Structures and Algorithms. This here is the solution for the second tutorial. So today we're looking at the singly linked list that we have studied during the past week, and we're working on tutorial number 2. Here's a tutorial statement. We have a few exercises over here, so if you can do these exercises, this should give you enough of practice. Of course, you would have to go and try the questions given at the end of the chapters by yourselves. So for the first question, we have a simple exercise that should pretty much revise your understanding of CS210. Write code to duplicate an array of type strings. So in NetBeans project, which is available on my website, this is the code that we've written together in the classroom. So I posted this thing as a zip file on my web page, and it's downloadable. So I've opened the same file in NetBeans over here, and I've created a new package over here called tutorial 2. So within this, I'm working on a bunch of these exercises. So you can find the solution for each one of these exercises over here. For instance, for question number 1, the solution is over here. So let's look at the solution. A simple method, you create an array D of type strings. We receive an array of type strings. We call that A as a parameter. So simply construct an array of type strings with this given size, which is equivalent to the size of the array A, and run a simple loop. So you can copy everything from every single element of the array A into array D. And at the end, we're going to return the newly created array. So that was simple enough. Let's go ahead and look at question number 2. Write class node with 4 of these fields: integer ID, string name, double GPA, and node next as members. Write a tester program to add 3 students. Provide your own details. Link all nodes so they can be accessed using a head pointer. So what we're going to do over here is we create our own class. Now notice this class is embedded inside the main class, which is Q2, which is a solution to my question number 2. So since this class is embedded, and you do not want to make a constructor inside my tester program, so I've declared this thing as static. Now I'm not declaring any methods whatsoever, not even the constructor, because I'm going to do everything manually over here. This is not a very good way of implementing, but just a revision for the concepts that we have learned and see how you can work with nodes. So what we do in the main method is we create a new reference n1. We assign it a new memory of type node. Of course, this is this node. And we manually go and put all the values. Since everything over here is public, this means everything can be accessed through the constructor. So n1.id equals 111. I've just assigned some values. Ahmed, GPA 2.9, and .next equals null. That's my first node, which is referenced by n1. Now create the second node, node n2, with these values. So ID is 222, name Muhammad, GPA is 3.3, and next value is null. Continuing, n3 is another node, and we put values 333, Ali 3.2, and null. So what we want to do is we want to make a chain out of this. What's required from us is that you're supposed to have a head pointer. So we want to give the illusion of a singly linked list. So what we do is we create a new head reference, node head, and we assign this reference or pointer to n1. So now the memory of n1 is pointed to by 2 different references, by n1 and head, because we just copied n1 on head. So we need to go and look into the memory of n1. We say n1.next equals n2. So the next pointer or reference which is stored inside N1, which is this one. So we're changing this thing to N2. Means that if I say N1.next, it's going to point to this memory location. And we continue with the third one also. We say N2.next equals N3. So this is N2. We're going to change this thing to N2.next equals N3. So now if I would like to access all of these nodes using my head, I can do this because all of these have been connected together. So if I want to print just the names of the people, I can do something like this. So head dot name. Obviously, this is the first name. Since head is pointing to the first node, which is N1, so this should give me Ahmed. Now if I say head dot next, this refers to this node dot next, which is pointing to this memory location. And if I say dot next dot name, so this is going to print the second name, which is Hamad. And now I can do the same for the third one. All I have to say is head dot next. So this gives me the second memory location, but I need to go to the third one. So I'm going to say next again, and then dot name. There you go. So this should print the third name, which is Ali. Let's give it a run. Let's see if it works fine. There you go. So first thing first. Alright, so I'm printing some garbage value. Why is that coming? Because I did not print the name, I'm printing the next. So this is effectively printing the address of the second node. So I'm going to change this thing to name and give it another run. There you go. So the first name is Ahmed, the second name is Muhammad, and the third name is Ali. So this is a solution for the second exercise. So let's move ahead. Look at question number 3. Give an algorithm to find the node before the last in a singly linked list. Use the node class from question number 2. So let's see how to do this. So what I did over here is I wrote a very simple method called find before last. I'm passing it an object of type slist2. Now I've modified this a little bit because in our implementation, the one that we did in the classroom, we had only one element inside that class node besides the next reference, which happened to be integer. So here, let me very quickly show you the changes that I've done. So in the node class, in the tutorial that I'm using over here, we have these 4 values: the integer ID, string name, double GPA, and node next. And I have very simple constructors over here which just initializes the values. So I'm just using this constructor. Now notice that just to make things easier for you, I've put everything as public, so everything inside a node could be easily accessible. Now looking at the implementation of the singly linked list, this is again very similar to the one we've defined in the regular classes. So again, no changes here, except of course the name of the class. But I have added a simple method called getSize, which simply returns the size of the array. And over here in the toString method, of course, I've modified this thing a little bit more. So instead of just displaying the temp.id, I also have the name and the GPA followed by the new line character. So this is it. This is the only difference we have in this implementation of singly linked list. So I'm going to close this for now, and let's move back to question number 3. So coming back to the question, so we have to go and find the node before the last. Now I have passed the object of type sList, and I'm returning the node. So what I do over here is I just declare a temporary pointer or reference t, and I make it point to s.head, which is a head stored inside my list object s. All I need to do is run a simple loop which goes from the beginning to the end of the list, and I'm just traversing t equals t.next and return t. So if I do -1, this is going to stop at one node before the end. So when I reach one node before the end, I'm just going to stop over there and return the pointer to this node. Hence, find the node before the last. Here's my tester program. Very simple code over here. I just declare a new sList. I run a loop and add to the last of it a bunch of these nodes. These nodes contain just a value I. Just to be sure, I'm going to put name plus I. So at least I have something inside the string name variable. All the GPAs are going to be 0 by default, and the next pointer is always null. So now what we're going to do is simply going to fill the array. So the first node is going to be 1, the second node is 2, 3, 4, and 5. Let's see. Give it a run. There you go. So my list is supposed to contain all the nodes from 1, 2, 3, 4, 5, and it's returning node number 4. So what we can do is, since we already have the method to string, I can simply call this. I can go ahead and print s, and this should take care of printing the entire list. There you go. So this is the first node, second node, third, fourth, and fifth. And since we're trying to get to one node before the last, which should be 4, so I'm printing s. So this is going to return a node, and node.id, which is 4. So here's a solution for this question. So we go ahead. Let's look at question number 4. Write Java code to add a new node in the beginning of a list. Use the node class from question number 2. So effectively, we're using the same class for the rest of the questions. So what we have to do is write simple code which is going to add new node in the beginning of the list. This should be easy. Let's look at question number 4. Let me hide this. And here we are. So simple add first method, which is passed a singly linked list and a node which already contains some values. So all I have to do is just attach this n to my list. So first thing first, we look at the node which is given to us, and we change its next to the head of my list, so that when I insert this thing in the list, this will become the new head. S.head equals n, and since n.next is pointing to the current head, so we effectively have the chain available as it should be. Here's a testing program. Same code. You create a new list. I'm going to fill it with some of these values. So again, just to make life easier for you, let's put some of these values. Now I create a new node, and let's say new students, and let's say his GPA is 3.0 and its ID is 101. So I can go ahead and add this, add first in my list, and add this node. So instead of doing this thing, I'll just go ahead and print my entire list. Let's run it. Here you go. So this student appears in the beginning, and the rest of the list is pushed down. So here's a solution for question number 4. Alright, moving on. Question number 5. Write a add middle method in this sList implementation that traverses to the middle of the list and inserts node n. Make sure you connect the .next reference to the next node. So this could be a little bit tricky. In the previous code, we inserted a node in the beginning of the list. Here we would like to insert in the middle of the list. So first what we have to do is find the middle of the list. let's see how to do that. So here's my implementation for question number 5. Here's a method called addMiddle. It's returning void and it's taking two parameters, the list and the new node which is given to us. So first we need to go and find the middle of the list. How to do that? So as we've learned in the class, we have to use a temporary reference to point to the middle of the list. So initially the only reference available to the list is through the head. So what I do is node t equals s.head. Now t is pointing to the head of the list. So we run a simple loop, integer I is 1, I is less than s.getSize, and we divide it by 2 just to get to the middle of the list. And we run this thing and we simply say t equals t.next. So when I is 1, t points to the first node, I++, t equals t.next, moves to the next node, and then the next node keeps going until this condition becomes false. So whenever this condition becomes false, we are effectively pointing t to the middle of the list. So what happens if the size of the list is even? That should be easy enough. Let's say the size is 4. So 4 divided by 2 is 2. So we start from 1. 1 is less than 2. True. So we go ahead, move to the second node. 2 is less than 2. No. So we stop there. So my t would be pointing to the second node in the list. Now, so in case if this is odd, let's say this is 7. So 7 divided by 2 will give you 3.5. Since this is integer, so the 0.5 is taken off, we get 3. And it will stop, the loop is going to stop at position number 3. Now what we do is, since t is pointing to the middle of the list, now what we do is we have to reinitialize the values inside the node which is given to me. So n is given to me, all I have to do is change its next. So I say n.next equals t.next. What that means is copy the reference which is stored over here, which is for the next node, into n.next. So we will just initialize the value of n. Now we say t.next equals n. So we have the t.next point to n. So this effectively is going to insert the node n inside the list. Let's see if we can run the tester program and see if it works. So here's my list. Again, let me put name over here. Right, so I'm creating 5 nodes. It's simply going to fill in all these values in there. Now I create a new node with the value 101. And I'm going to say new student with some GPA. And we're going to add this in the middle. And let's see if it inserts this thing in the middle. Run the file. Here we go. So since the length of the list was 5, which is an odd number, so 5 divided by 2 will give me 2.5, which is effectively integer typecast to 2. So it stops at location number 2. Here's what I'm going to do. Add the new node. Have this node point to the next node over here. And this node point to this node. So this is effectively put in the middle of the list. What if the size was even? Let's make it 6 and see if it works. Run again. There you go. So it gets me after 3 because 6 divided by 2 is 3. So at the end of 3, the new node is attached, and the next to the new node points to the number 4. Okay, moving on to question number 6. Write a find ID method that traverses the list for a node containing ID of a student. It returns pointer to this node. So simple enough. We've done something similar to this in the classroom. So this is just added practice. Let's look at question number 6. I'm going to hide this. Here's a simple implementation of that. So find ID is returning a node reference. It's passed 2 parameters. The first one is of course the list, and the second one is an integer I. This is the value we're looking for. So what we always do, create a temporary node t and have it point to the s.head, the head of the list. Now we run a simple loop. Now this time I'm using a while loop. Obviously you can use the for loop over here if you like to go with the size, but here, just for the simplicity's sake, we're working with the while loop. So while t.next is not equal to null, if t.id equal 1, equal I, so we're going to return t. If that is not the case, we're just going to move on to the next node. So what happens is, imagine if the list is containing only one node. So in that case, t.next or head.next should have to be empty. So if that is the case, we do not go inside the loop and we simply return null. Now if it has multiple nodes in there, what we can do is run through all these nodes. So while t.next is not equal to null, if t.id equal I, if I find the node which contains a value I as ID in the node, I'm simply going to return t. Now here we have something missing, which probably you should investigate some time in. What if the list is empty? What's going to happen? In this case, t.next would probably crash because t does not exist. T itself is next. So you have to put a condition over here which is to check if the list is empty. Here's another case. What if the size of the list is only 1, which means the head exists, but there's nothing after the head. So in that case, while t equals s.head, it will contain one value, and when you go over here, t.next, which is in effect null, because there's no other node after this, so we'll never get into this loop. So you also have to take care of this case over here. So anyways, let's look at the tester program. Here's my tester program. I add the same values in my list. Node t equals find id in the list, and I'm looking for id number 4. So if t is not equal to null, this means that we have found a value. I'm just going to print the name of the student. If not, simply display a message not found. So run the program. There you go. We found 4, so it's there. What if I'm looking for is not there? Let's see, 100. Obviously, I never put 100 because the loop runs only up to 5. So let's see, not found. Right. So the two cases I talked about earlier, you can consider that in this implementation. So moving on to the last question. Write a bring to first method that traverses the list for a node containing ID of a student. It detaches this node from the list and attaches it to the head of the list. So this is a little bit tricky, and let's see how it works. So what we have to do is we have to go and find a node which contains ID of the student. If you find it, this means what we would like to do is we want to remove it from the list and then put it in the head of the list. So effectively we're doing two things over here. In the class we learned how to remove something from the list and also add something to the list. So we wrote two methods which were, if I look at my slist implementation, we wrote add first and add last. We also wrote remove first and remove last. So here in this question what we're going to do is first we'll try to find the node. So here's my implementation. I'm returning boolean, successful or unsuccessful, true or false. Bring to first, I have a list, and this is the node, this is the value I would be looking for in the list. So as before, node t equals s.head. Now it's a little bit tricky because now we have to work with the previous value. Remember, what we studied in the class was how do you detach, when I want to remove something from the list, I have to find the previous node. So this is why I'm using this, and I'm being a little bit clever because I'm just having one loop over here instead of two loops to find the previous and the next value. So how does that work? While t.next is not equal to null, if t.id equal I, this means the node that I'm looking for is this one. So break the loop. If this is not the case, what I'm going to do is I'm simply going to say previous equals t. So previous is just a reference which is going to remember where the current position of t is. So once this is done, I move on. I simply move the t to the next value. So after the loop is completed, the previous is pointing to the node which comes before the current value of t. So this way, whenever the loop is finished, t is effectively pointing to something that I've found, and previous is pointing to the memory location which is one before the t. So here we have some cases. What if t is null? Means the list was probably empty. Or what if I didn't find I in my list? Yeah, let's say I was looking for a value which I couldn't find in the list. So in both cases, I'm simply going to return false, means failed. All right, now here's another check. Check if t is the head. So if this happens to be the case, this means I will not have to detach this node and reattach it. It's already there. Just simply return true. So out of these two, this means that I found a node which is in the middle somewhere of the list, and I would like to have it detached. So detaching is pretty simple. All I have to do is previous.next equals t.next. So my t is already pointing to the node that I want to get rid of. So all I have to do is previous.next equals t.next. So the previous node now is going to point to the next node of the t. Now once this is done, this is simple detaching. Just one line detaches this node, detaches t from the list. Now all I have to do is put this back in the first place. So t.next equals s.head. So t.next points to the current head of the list, and I move the current head of the list to this new t. So simple as that. Let's see, it's a simple tester program. So very similar code to before. I've created a list with 5 nodes in there. Bring to first, I'm going to bring the number 1 to the first. Remember, in our implementation, it always goes like 1, 2, 3, 4, 5. So first node means this case is true. If t equal head, we do not do anything, we just simply return true. Alright, in this case, we're looking for 100. In the list, I never stored 100, so this node is not there. So again, this would be the case. Either it's empty or we couldn't find, so it's going to return false, means no change. Here, we'd like to move 4 to the beginning of the list. So this should detach 4 from the middle of the list and put it in the beginning. Let's test this. There you go. So in the first case, when I wanted to bring number 1 to the head, so since this is already at the head, we do not do anything. In this case, we're looking for 100, which does not exist, so no changes here. In this case, we're looking for 4, so we detach 4 from the middle of the list and put in the beginning. So this concludes our tutorial, and thank you for listening.